Hello geometry students and welcome back to another video. So, you know what to do. Pause the video, try this problem in your notes, and then unpause it to do it with me. Okay, can you assume that plane S intersects plane T at line BC? I'm not sure why that arrow is off a little bit, but we want to know if plane S, so this plane, as I can see by the S in the corner, and plane T, do they intersect at line BC? Can I tell this from the diagram? Yes. Yes, I can, because notice the corners here. Let's unmuddy up this diagram. Notice the planes meet at this corner right here, and the planes meet at this corner right here. Those corners match at BC. So yes, we can assume that. Now, explain how you know that line AB is perpendicular to line BC. So AB is perpendicular to line BC. Okay. So what does this little half square mean? It means that AB is perpendicular to plane S. So we know line AB is perpendicular. That's what this upside down T means. It means perpendicular. Perpendicular to plane S because it is marked. It is marked on the diagram. Whoops, diagram. And BC lies in, so line BC lies in plane S, and any line perpendicular to a plane is perpendicular to all lines in that plane. So AB is parallel to, or excuse me, not parallel, the opposite of parallel, is perpendicular to line BC because this symbol tells us that it's perpendicular to plane S, and if it's perpendicular to plane S, it's perpendicular to all the lines in plane S, and BC is contained in plane S. We know that because it is the intersection of plane S and plane T. So there you go. There is our entry task problem. Hopefully it felt good. If not, make sure that you talk to your teacher or that you completely understand the answer we have here. Now we move on to section 2.4. This section is all about algebraic reasoning. So hopefully this section feels familiar because a lot of this section is about algebra, and we just finished algebra. So our learning target is that you know what algebraic properties are. It has been a while since you've seen these, probably, so we're going to brush up on them. And then our success criteria is that you can use those algebraic properties to justify steps in solving an equation. So we're going to go back to solving equations, but we're going to use algebraic properties to do so. So let me remind you of the algebraic properties. We have the addition property of equality, subtraction property of equality, multiplication property of equality, and division property of equality. Substitution property of equality is a tiny bit different, so I'm going to talk about these first. What all of these say is that if I have an equation, A equals B, 3 equals 3, some true statement, then if I add something to both sides, Like here, yeah, let's go back to the 3 equals 3. If I add the same thing to both sides, I add c, or I add, so say c is 2. If I add 2 to both sides, I still get 5 equals 5. That is still a true statement. So anytime you add something to both sides of the equation, you're using the addition property of equality. Anytime you subtract something from both sides, you're using the subtraction property of equality. You see the pattern here? Anytime you multiply something that isn't 0, and if you want to know why you can't multiply by 0, we need to go back to section 1.1 of algebra. And that's okay, you can go revisit that if you want to. I didn't mean that you need to go back there, I meant that you could revisit it. There's no shame in forgetting any of this. So if you multiply the same thing to both sides of the equation, you're using the multiplication property of equality. And if you divide something on both sides, but remember it can't be 0, because if you divide by 0, the world will explode. If you divide by something on both sides, you're using the division property of equality. For the same reason I stated up here. You can do this same thing with any of these. So you can start with 3 equals 3 and you can subtract something from both sides and you still get a true statement. You can multiply by something on both sides and you still get a true statement. And you can divide, you get it. You get what I'm saying. Now, the substitution property of equality is a little bit different, but you have used it before in algebra. If A equals B, then A can be substituted for B, or B for A, in any equation or expression. Now, you've seen this before, but we'll see an example of it in later on. So now let's use all of these algebraic properties to justify steps, shall we? Let's just jump right into it. So, I have 3x plus 2 equals 23 minus 4x. So I'm gonna do the steps over here, and I'm going to justify them over here. So this is what we start with. We start with this. We were given this. When I say we were given, I mean the problem gave it to us. Literally, somebody gave us this problem. Okay, now remember, to solve, I want to get my x's on one side and my numbers on the other side. So I'm going to add 4x to both sides of the equation, and that gets rid of this. Now, why am I allowed to do that? Why am I allowed to add 4x? Remember, I have to justify. And justify means explain. Explain why. So why am I allowed to do this? Why am I allowed to add 4x to both sides? Well, remember that our addition property of equality told us that if we add something to both sides, as long as it's the same thing, if we're adding the same thing to both sides of the equation, it's good. We can do that. We can add the same thing to both sides of an equation and still have an equivalent equation. So, our justification for this step will be the addition property of equality. Oh, equality. Because this property is what tells us it's okay to add 4x. So this is why we're allowed to do that. Okay, so we get 12x plus 2 equals 23. Now, some people say that you need to justify this step. Some people say, nah, doesn't matter, it's so simple. If you want to truly justify every single step, from here to here, how did we get from here to here? Well, we combined like terms. We combined the 3 and the 4x together. So you can say combine like terms. You could also say simplify, as long as you're just saying what you're doing to get from one step to the other. So combine like terms, simplify, same thing. It's however you want to say it. It's your proof. Okay. So Now we have 12x plus 2 equals 23. Now to continue solving, I'm going to subtract 2 from both sides. Why am I allowed to do that? Because of the subtraction property of equality. So that's what I'll write here. Subtraction property of equality. All right, let's continue our steps. We have 12x equals 23 minus 2 is 21. Wait a minute. I'm sorry, I just noticed that 3 plus 4 is not 12. Holy cow. Look at that, even math teachers make mistakes. That should be 7x, not 12. Okay. If you caught that, good job. Good for you. Okay. So remember, this step is combine like terms or simplify. Doesn't matter, whichever one you want to use. And now to continue, I'm going to divide by 7 on both sides. Why am I allowed to do that? It's the division property of equality. Property of equality. Okay, and then I get x equals 3, and that, again, that was just simplifying to get there. Ta-da! So we have completely solved. It told us to solve and justify each step. We solved it because we have x by itself. We solved for x, and look at that. We justified every single step. So there you have it. We can make sure we were correct. Given, addition property, simplify, subtraction property, simplify, division property. Boom. Same thing. We did the same thing. Okay. Now, I'm going to tell you about another property from algebra, the distributive property. Hopefully you remember this one. This is where if you have a number on the outside, you can distribute it to everything inside the parentheses, and you just multiply it to everything inside the parentheses. So a times b, you have a times b, and then a times c, you have a times c, and because there's a plus in between them, there's a plus in between them. And same thing, but with subtraction over here. So, if you were ever doing an algebra problem where it said to justify your steps, and you use the distributive property, if you were to justify, you would say, I used the distributive property. So let's see an example of that, using the distributive property. So, solve negative 5 times 7w plus 8 equals 30. So we'll solve over here and we'll justify over here. So this is what we are given. You always start with your given. And now I am going to use the distributive property because anytime I have parentheses, I need to use the distributive property when I'm solving. So I have negative 35w minus 40 equals 30. And what got me from this step to this step? The distributive property. So my justification is the distributive property. Okay, next I'm going to add 40 to both sides. Why am I allowed to do that? Well, the addition property of equality. Okay, and then I have negative 35w equals 70. And remember, that was just combining like terms or simplifying, whichever you prefer. Now I'm going to divide by negative 35 on both sides. Why am I allowed to do that? Say it. Yeah. Division property. Division property of equality. And now we have W equals -2. And that's, again, that's just simplifying from here to here. Okay, look at that. We solved and we justified every step. So we can check ourselves. Given distributive property, addition property, division property. They didn't add the simplify between each step, because some people say, well, duh, you simplify. You don't even need to write down that step because it's just so obvious. So some people write down simplify, some people don't. You will need to ask your teacher which one they want you to do. I like you to write simplify because I like to see your proofs. I like to see every little detail of your proofs. So, and we got -2, which was correct. So, put simplify in your proofs if you're one of my students. Okay, now, our last example is a real-life problem, and it actually is. I put it in quotes, but this is actually totally a real-life problem. My husband and I did this the other day because he got a raise at his job, but they didn't tell him how much of a raise it was. They just gave him another paycheck, so we were trying to calculate, was it a 2% raise? Was it a 3% raise? And this problem is going to tell you, well, when we do it, you're going to learn how to calculate your wage or your raise as a percentage. So, you get a raise at your part-time job. To write your raise as a percent, use the formula this. P times R plus 1 equals N, where P is your previous wage, so this is what you're getting paid right now. R is the percent increase, so that's your raise as a percentage, but you want to write it as a decimal. And N is your new wage, so that's what you're getting paid now. So solve the formula for R. Okay. So, first thing, it told us to solve the formula for R, so that's what we're going to do. I'm going to get R by itself, which means I need to divide P on both sides. And let's see, am I supposed to be justifying my steps? It didn't say to justify my steps, so I guess I won't, but I will. This is the division property of equality, but I'm not going to write of equality. Okay, so the P goes away. Now I have R plus 1 equals N divided by P. And to get R by itself, I'm going to subtract 1 from both sides. That's the subtraction property. Subtraction property. And now I have R equals N over P minus 1. That R looks funny. R. Okay. We have solved the formula for R. What does it want us to do next? What is your raise written as a percent when your hourly wage increases from $7.25 to $7.54 per hour? Now, I know what some of you are thinking. Minimum wage is not $7.25. Actually, in Iowa, minimum wage is still $7.25. So, be very grateful. I mean, also housing prices and, like, the cost of living in Washington is so much higher. That's why our minimum wage is higher. But also, be thankful you don't live in Iowa. Okay, so this is our previous wage. This is our previous wage, P, because that's what our what we were getting paid to start with. Now we're getting paid this, so this is our new wage, or N. So we're just going to take, and here, I'll actually do a different color for this part. We're going to take both of these things, and we're going to put them into this equation right here. So R equals N, or $7.54, divided by P, our previous wage, $7.25, minus 1. And this is 7.54 divided by 7.25. That is 1.04 minus 1, which is 0.04. Am I done? I got a 0.04% raise? No! Remember that R is a decimal. We want to know what the percent is. So we have to change this decimal to a percent. The way that you change a decimal to a percent is you multiply by 100, and that, whoop, whoop, it moves the decimal over 2 places. So this is a 4% raise. That's not that bad. 4% raise is pretty good. I mean, maybe not at this low of a wage. Maybe it's not as good, but it's still 4%. 4%. All right, we can check and make sure that we were right. Oh, they justified, even though they didn't say to. That's okay. All right, but the important thing is that they also got 4% raise. So, yay. Okay, that is what I have for you today. We're going to talk more about reasoning in algebraic reasoning in the next video. But if you have any questions on what we did today, please talk to your teacher, talk to a friend, talk to somebody. What we did today is actually we laid the foundation for proofs, and we're going to talk more about proofs in the next video. But those are proofs. What we just did in those examples, those are proofs. So, congratulations on doing your first proof. And if you had any questions about it, talk to your teacher. Proofs aren't as scary as you think they are. We're going to talk more about that in the next video. So here are some practice problems that you can do to get more comfortable with the skills taught in this video. And you can see examples 1 and 2, example 3. Yes. So, try these problems, but also make sure you're doing the homework your teacher assigns. And as usual, we're going to end our video with a launch. So this launch comes from Deep Roy, and he says, inspiration comes from within yourself. One has to, but you have to be positive. When you're positive, good things happen. And it's not that when you're positive, like, better things happen, that like, oh, if you're positive, you'll win the lottery and a dog will come up on your porch and be your best friend forever that doesn't have rabies. Like, that's not necessarily what we're saying. What we're saying is that when you have a positive outlook on life, when you look at things more positively, you'll see them as positive. And that's why good things happen, because you're interpreting them as good instead of as bad. There are a lot of things that you can go, oh my gosh, this is horrible, this is such a bad thing, and then 3 days later you can go, oh, I guess it wasn't that bad. Something that I read in a book back in high school, I don't remember the book, I'm not sure if I do, but in high school I remember reading, anytime you get really upset about something, ask yourself this: in 5 years, will it matter? 5 years from now, will I be upset that I stained a shirt and had to throw it away? Couldn't get the stain out of it? Will I be upset about that? If I will, if it was really my absolute favorite shirt, or my grandma gave me that shirt and now my grandma's not with me anymore, like, maybe you will still be upset about it in 5 years. And then, like, yeah, be upset, talk to people, get that worked through. But sometimes, like, I dropped a glass and broke it the other day. In 5 years, I'm gonna have a new cup. Doesn't matter. Like, it's not gonna matter in 5 years. So, that can be a fun little check. Well, not fun, but, you know, it can be a check for you. Like, do I really need to be upset about this? If you're gonna be upset about it in 5 years, yeah, this is something to be upset about. But if it's not gonna matter in 5 years, maybe you don't need to be upset about it. So that is my launch for you today. Take it with you as you go throughout your day, and have a wonderful rest of your day. Thank you so much for being here. Thanks for watching.